So moving into section 6.6, we're talking about things called vectors. And to understand what a vector is, give a pretty basic example. So let's say that you're driving home one day and you're driving along US 41 and you're going 70 in a 45. Well, chances are you're going to get pulled over for going that fast. Something very strange is going on. But when you're going that fast, the cop's not going to care about why you're going in that direction. The cop's not going to care about why you're in a hurry or why you're going one way or the other. They're just going to note your speed, specifically that your speed is too high for where you are. They are noticing what is called the scalar measurement there, where all you're looking at is the magnitude of the measurement, the value. Whereas for you, you're probably pretty concerned about where you're going if you're trying to get there that quickly. Say you're driving south towards Naples or Miami, you probably have a reason to be there if you're going to be going that fast. So, if you're thinking about it not just in terms of speed, but you're also including direction, you get an idea called a vector. Vectors have both magnitude and direction. It comes from a Latin word in particular meaning carrier. So you can think of what a vector does as carrying something from point A to point B. So if we've got U starting from point A, going towards point B, this ray, this directed line segment, is the vector you're following, where you care both about how fast you're moving and the fact that you are going in that specific direction. We're going to talk about this stuff more in terms of our specific notation and a little bit more history on this as well in this section, where we're going to see actually that vectors behave very similarly to what we saw earlier in chapter 8 with matrices. And that's actually important and intentional, because even though we're not going to see it much in this class, if you see up to linear algebra with this stuff, you'll actually talk about that relationship, that matrices can be seen in a sense as being built out of vectors. But for now, we're just going to focus on the basics.